This video is going to cover the topic of scaling probability. Be sure the date and topic are at the top of your page. The essential question asks, how do we use probability to make predictions about events? So far, we have seen probabilities that can be written as a ratio. We know that probability is a ratio of the number of times an event occurs, or theoretically should occur, out of the number of possible events, right? So thinking about our marbles, if in my bag of marbles there are 3 yellow out of a total of 8 marbles, I know my probability is 3 out of 8, or 3/8. So what we can do from here is we can use this ratio to make predictions about how often an event will occur in the future, or if we want to scale it up. And we do that by thinking about equivalent ratios as equivalent fractions and vice versa. So in 6th grade, we learned about equivalent fractions and also equivalent ratios. For example, we learned that 1/4 is equivalent to 2/8, right? That's nothing new. I can, however, prove that to us, right? I can prove that that's true because both the numerator here and the numerator here and the denominator on the bottom were increased by the same scale. In this case, they were both doubled. You'll also hear me refer to that as a scale of 2 because they were both multiplied by 2. So the scale here was 2. They both increased by 2. The other term we use to describe these is a big one. I'm going to put a little bubble around it, and that is proportions. These are proportional to one another. And we talk about all of this because this can also help us with our probability ratios to predict how often something might occur. Let's think about the example of the number cube, right? So if we want to know the probability of rolling a 3, right? Well, we know that there are 6 sides with 6 different numbers, and I'm looking for one outcome, right? That is 1 out of 6. That is my ratio of what I hope to get, the 3, out of all of my possible options, which are 6, right? So it's 1 out of 6. And I can use that to make predictions, right? So how many times do you think we would get a 3 if we rolled this number cube 30 times? One way to make this prediction is to think of it as setting up an equivalent ratio or an equivalent proportion, right? To make proportions. So I'm going to start with what I know, which is that my likelihood is 1 out of 6. And I'm trying to figure out what it is out of 30, right? So I want my total number of trials, right? My total number of events to be 30. And what I'm looking for here is my missing value, my missing numerator. So I want to make sure I keep my ratios equivalent, and I'm thinking, of course, to myself that, oh, if I multiply 6 times 5, I get 30. And whatever I do to the denominator, I need to do to the numerator. So I would do 1 times 5, and of course 1 times 5 is 5. So I would expect that if I rolled it 30 times, about 5 of those times I would get the number 3. Now we know from previous work that what happens in an experiment or with experimental probability is not always what we would hope or expect to come in theory. So I'm going to make sure that I'm really clear about this approximately, right? We don't know for sure. We can't bet our lives on it that we'll get it 5 times if we roll it 30 total turns, but we should get it approximately 5 times. Let's look at another example. So this example looks at cookies, and in this batch of cookies, some of the cookies have 5 chocolate chips. So I'll make that a little clearer here. So these have 5 chocolate chips in them. Some of the cookies have 8 chocolate chips, and a few of them even have 10 chocolate chips, right? There are 10 cookies in all, and I'm thinking to myself, if I have a batch of 300 cookies, how many would have at least 8 chocolate chips? I want my answer to be an educated answer, right? So I'm not just going to guess. I'm going to use what I know about probability and look at the chance that I have right now of having at least 8 chocolate chips and scale that up to figure out how many out of 300 cookies would have at least 8 chocolate chips. So of course, to start, I'm going to look and see what I have available to me. I know there are 10 total cookies, right? So that's my sample size, right? And I know that 6 of them, 1, 2, 3, 4, 5, 6 of them have 8 or more, right? At least 8 chocolate chips, right? So I'm going to set that up as a ratio, 6 out of 10. And now I'm going to think about an equivalent ratio. And I want it this time to be out of 300, right? And so I'm going to think about my scale. What did I need to multiply 10 by to get 300? And some of us might know kind of quickly what that is. So you might be thinking to yourself, oh, she multiplied times 30, and therefore I would multiply my numerator times 30, and 6 times 30 is 180. So I should expect there would be approximately 180 cookies that have at least 8 chips, right? But of course, if jumping from 10 to 300 was kind of a big jump, you can always do your proportions in parts, right? So I do know that 10 times 10 gets us to 100, right? That's a good stepping stone. And 6 times 10 is 60. And then it's a little bit more friendly. I can just say, oh, 103 times makes 300, so I multiply 60 times 3 to get 180. Either way, I'll have a good sense of how many cookies will have at least 8 chips, right? The more chips, the better, in my opinion. And again, this is just an approximation. We would think it would be logically about 180, but we can't say with guaranteed certainty, as we know from our work in the past. We can't say exactly 180, but it's a good number for us to assume would be appropriate. So of course, remember this video, the essential question was how do we use probability to make predictions? And hopefully you can see that since probabilities can be written as ratios, we can use proportions or equivalent ratios to make predictions about larger scale events.